Hello students. So we are going to do a test discussion. I'm going to explain you the different solutions the test you had. Now let's just get started with the first question. A particle is moving parallel to x-axis as shown in the figure, such that all the constants or all the instants, the y component of its position vector is constant. Okay, so this y component of the position vector, this is the position vector itself. X component is this and y component is this, and that's constant, which is b. Alright. Now the angular velocity of the particle p about the origin at the given instant is. Now see, there are different ways of doing this problem. Now let me tell you one way. Now this is v and this is theta. Now I can decompose this vector into two. I can call this v cos theta and I can call this v sin theta. In fact, if you see, v cos theta is the radial component, right? While v sin theta is the tangential component. Now this is exactly what helps you, what looks like it's rotating about a center. Alright. Now if this is b, which means this is b, this will be b by sin theta. So directly I can say omega is b by r. Right, so it will be v sin theta by r is b over sin theta. So we'll get it as v by b sin square theta. This is your omega. Is it clear? Right. Let's go ahead with the next question. Now this question is from AC. In the circuit given below, shown in the figure, the AC source gives a voltage V. V is 2 cos 2000 into T. Right, now what is this V again? V is the peak voltage. So from this I can also say that omega is 2000. Now neglecting the source resistance, the voltmeter and the ammeter reading will be. Okay, now this is the case. So there is an L, there is a R, there is a C, and there is an ammeter here, voltmeter here. Now we want the voltage across these three electrical components, not 6 included, but the current will be the current drawn from the source itself. Alright. Now if you can see, this particular resistor can be slowly slid into 4, because anyways it's just potential drop in 1 and 2 together, right? So I can just call it I into R1 plus R2. In the sense it will become 10. So the circuit will become this. 10. This is 50 microfarad and 5 milli Henry. 50 microfarad. So we know very well. So R now is 10. Now what about impedance? XC. XC is 1 by omega C, which is 1 by 2000 into C is 50, right? 50. Yeah. 50 into 10 to the power minus 6, right? XC will also be 10 ohms, right? Now what about XL? XL is omega into L, isn't it? So omega is again 2000 into 5 milli, 5 into 10 to the power minus 3. So it's 2 upon and it will become 10 ohms. Right. So what is the impedance? Impedance would be root over 10 square plus 10 minus 10 whole square. Okay, which becomes 10 itself. Alright. Are you getting it? So here exactly, if you see, if you take the phasor of current and if you take the phasor of voltage, they're in same phase. Right. Basically we are talking about resonance here. So this particular circuit is in resonance with the supplied voltage. Okay. Now that's not the point right now. So we got the impedance. Now from there I know current would be potential divided by impedance. Okay. So 20 divided by 10 is 2 amperes. See, this is the peak current because 20 is peak voltage, right? So I want RMS value, which will be 2 by root 2, which is root 2 by root 2. It is root 2. So it's going to be 1.4 amperes. So either this or this. Naturally, this cannot be 0, and the answer is this. But even then, how do we find it? Okay. Now, what is the potential I want? Okay. Now I want the potential across this. Listen. So the current here in this is root 2. Now the potential drop is root 2 times. What is the resistance here? Resistance is 4. So you'll get 4 times 1.4, which is 5.6. That's your answer. Okay, this circuit is in resonance. Noteworthy. Next question. A current I flows along the length of a infinitely long, straight, and thin walled pipe. So this is the pipe. So current is going across the pipe, through the pipe, in that small cross section area. Now, then the magnetic field at any point inside the pipe is 0. See, for this case, we have to apply Ampere circuital law. So if you take this as the the pipe, let's say current is going inward like this inside that's thin, so I'm not drawing it inside. Now I want field here. Now anywhere I take an Ampere loop, isn't it? Okay, there is no current that is enclosing this. The current will start being enclosed only when you go out for taking an Ampere loop. So any loop inside will have no current, which means integral B dot dl is mu sigma I. This sigma I becomes 0, so naturally this becomes 0. Now the reason that they are saying is also this. So what is it? So both assertion and reason are true. The reason is the correct explanation of. Alright? Let's go to the next question. The susceptibility versus 1 by T graph is for a alloy of a paramagnetic nature is shown in the figure. The Curie constant is okay. Now what is Curie's law? So Curie's law says susceptibility is inversely proportional to time t. So E is equals to Curie's constant divided by the temperature. Now this graph is not relating susceptibility with temperature, it's directly relating susceptibility with 1 by T. So C will become susceptibility over 1 by T. And you can pick any of the points, like you can, let's pick this 4. So when this is at 4, and it is 0, susceptibility is 0.2. 0.2 divided by 4 into 10 to the power minus 3. Alright. So what are the options we have? 57. 0.4 if you take. Okay, listen, we can pick this point actually. So if you take 0.4 divided by 1 by 7 is 10 into 10 to the power minus 3, it should be 400 over 7. Doesn't it? 400 over 7 is almost 6, because 420 times 7 if you take, you'll get 60. So it will be a little less than 60, which is 57. Alright, that's it. So one important thing is it's x over 1 by t, it's not x into t. Next question. A vehicle of 100 kg is moving with a velocity v is equals to 5 meters per second. This is 100. And it stops to stop it in 1 second. Now it's 1 by 10th of a second, the required forces. What's the acceleration that it would suffer actually? V minus, 0 minus 5, v minus u by t, 1 by 10. So it will be 50. Minus 50, it's in the opposite direction. Right. Ma is equals to force. So 100 into 50 gives you the force, which is 5,000. One mistake that students might do, you might just call it as 10 seconds. What will happen then? So minus 5 by 10, you'll get 0.5, and then 0.5 times 100, you would actually get 50 newtons, and this is also there in the option. Okay, so be very careful. This time is 1 by 10th of a second. It requires to be stopped even in a lesser time, much lesser time, not 10 seconds. It's 100 times. Right, it's 100 times. That's the reason we need more force comparatively. Okay, two bodies of equal masses moving along the same horizontal line with speed 3 plus 3 and minus 5 respectively collide elastically, and then their velocities after the collision will be, this is obvious. If both of them have same mass, they would actually exchange their velocities. So this will be minus 5 and this will be plus 3. So the answer is Q. Next question. Two assumptions y1 equals to a sine omega t and y2 is a cos omega t are superimposed on a particle of mass. The total mechanical energy of the particle is, see, the mechanical energy is half m omega square a square. But I want to know what is the amplitude a1 square. I want to know what is the amplitude of this combination. So the amplitude will be, one phasor would be like this, the other phasor would be perpendicular to that. Right? The amplitude will be a root 2a. So it's half m omega square 2a square. So 2 is gone. Omega square a square is your answer. It's option B. Alright, let's go to the next question. Now the refractive index of the prism is root 7 by 3 and the angle of the prism is 60 degrees. The minimum angle of incidence of the ray so that it will be transmitted through the prism is, okay, now listen carefully. There is a prism like this, okay. So prism like this. This angle of the prism is 60 degrees. So you are sending some light over here and then it goes, and at this point I want it to be transmitted. So if you take a critical case, it should actually graze through the point. Okay, look at this carefully, isn't it? Now let's call this, now this angle must be minimum critical angle. Okay, so let's put some angles now. This is R1, this is R2, and then again let's call this angle as I. Okay, now we have to do this problem in the reverse way, coming back from the R3. Now listen, I know very well this R1 or like R2. See, this R2 must be less than critical angle. It does. Okay, this is one case. Now, if R2 should be less than critical angle, how will you arrive at R1? And we know very well that R1 plus R2 must be equals to A, isn't it? So R1, R2 is A minus R1. A minus R1 must be less than the critical angle. Alright, so minus R1 is less than minus A. So R1 must be greater than A minus theta C. Okay, which means you put it aside. So then you'll get A minus R1. Theta goes that side, it becomes theta C. Okay, these two are the equations. Okay, so now if you put them together, so R1 must be greater than A minus theta C. Okay, now this is where we need to do a little magic. So apply sine on both sides. It will be sine A minus theta C. So sine R1 should be greater than sine A sine B, sine A sine theta C minus cos A cos theta C. Alright. Now is this sine or cos? Wait a minute. There's a problem. It should be cos. Sine A cos B minus cos A sine B. Yeah. Sine A cos theta C minus cos A into sine theta C. Alright. So, but look at this here. Now, if you apply Snell's law, sine I must be equals to mu times sine R1. So, sine R1 is sine I by mu. Okay, which means it will be sine I by mu. That is greater than, what is sine A? A is 60. So, I'll write it here, root 3 by 2 into, what is critical angle? Theta C. Now, what is critical angle? Sine inverse 1 by mu. So, sine inverse root 3 by 7. Okay. So, now if you put it up like that, So this is root 3, this is root 7. Now what will this be? So 7 square plus 8 square, 3 square minus 3 square. No, root 7 square minus root 3 square, it is 4. So it will be root 4. Okay, this is theta c. So sine theta c is root 3 over 7, but cos theta c is root 4 over 7, isn't it? So it will become root 4 over 7 minus cos A is cos 60 half, sin theta c is root, which is that, 3 over 7. Okay, but this is 1 by mu. 1 by mu is root 3 by 7. So root 3 over 7 sin I, write it clearly, must be greater than root 3 by 2, which is root 4 by root 7 minus half root 3 by root 7. Okay, now listen carefully. Root 3 is gone here, here, and here. And so root 7 is gone here, here, and here. Now write it carefully. It will become sine theta c. No, it's not theta. It's actually I. Sorry. So sine I must be greater than. So root 4 is 2, 2 is 1, and it will just be half. That's it. So it is 30 degrees. Okay, that's it. It's a good problem. Next one. In a Young's double slit experiment, coherent monochromatic light of wavelength 600 nanometers has fallen on slits. The first bright, so first bright is lambda d over d. This is 4.84. Now, if the central from the central maximum, determine the wavelength for which the first order dark fringe. First order dark fringe, this is the order of it, n minus half d minus d by d. That should also be 4.84. That's what they said, and this is d dash. But n is 1. So I'll say lambda dash d by 2d. That should be equal to lambda d by d. Con lambda dash is 2 times lambda. You don't need any other information. It's just directly 2 times 600 is 1200. Pretty easy question. Look at this question. Two capacitors having capacitance C1 and C2 are connected in series and with a potential difference V is applied across them. Then the C1, C2, V. Now see the one common thing, one important fact that we are using right now, or we are going to use right now, is that same charge in series. Okay, so if you take this as C1, C2, Q1, same Q. It's not Q1, Q2 minus Q plus Q minus Q. So Q is the same thing, but what is a drop here? V1 would be what? V1 would be Q by C1. V2 would be Q by C2. So more capacity will have less drop. Okay, less capacity will have more drop. Or I can tell you like this, it takes more potential difference to feed the guy with less capacity for the same amount as same amount of the another capacitor. Okay, you have to feed this much charge for something which has less capacity, let's say. Okay, so V is inversely proportional. See what it means is, if the capacitance is less, you need more potential difference to actually charge it for the same amount of charge. That's it. That's the whole point. Okay, now let's go what they're asking. So if V1 is less than V2, V1 is less than V2, V is inversely proportional to C. If V1 is less than V2, C1 should be greater than C2. So it is Q. Okay, this or this. Now, U1 is less than U2. Now again, U has a lot of formulas. You can also use half CV square. But you cannot use this because there is nothing common in this case. There is no unification factor. So if I use U as Q square by 2C, now I know Q is common for both. I can directly compare it. U is inversely proportional to C. Same thing, just like potential U. So the same thing works. So this is also Q. What about C? V1. Okay, how about we get V1? So it is pretty simple. Now if both of them are combined together, there is a series combination. Now we know very well that C equivalent into V will be the charge. Actually the charge stored inside this particular combination. C equivalent is C1 C2 V by C1 plus C2. This is charge Q. Now what is V1? V1 would be Q by C1. Okay, so C1 C2 V over C1 plus C2 to 1 by C1. So C1 C1 1 C2 V by C1 plus C2. Similarly, this will be C1 V plus C1 plus C2. So when you have V1, there should be C2, which is S, and this is R. So the answer is A. Right. Let's go ahead. A changing electric field produces magnetic field. Now the direction of the magnetic field. Now this is directly from electromagnetic waves. You know very well that one oscillates in X or Y, the other should oscillate in Z. Only because of one field, the other field is getting produced. So it will be perpendicular to the direction of the electric field. Both of them are related. Now, what about this? The radius of the conducting loop shown in the figure, the magnetic field is decreasing at a constant rate alpha. So there is area, which means there is B dot A, definitely, and this is a decreasing, which means there is a rate of change. So there will be an EMF induced. Okay. Now, what will be the direction of the EMF induced? So it is dropping down. So field is dropping down, isn't it? Decreasing at a constant rate. So field is dropping down. So in this cross direction, it is dropping down. So whatever this guy produces, there are two loops over here. Whatever it's producing should be in clockwise direction. Okay. So which means this. So it will go like this. So the magnetic field produced must be in that direction, cross. So the current will actually go in this way, like this and like this. Now the same thing happens here, clockwise. But the thing here is, the current here again would be like this, no problem here, but the current would be like this. So these two will actually cancel each other, there won't be any current. But there will be current across it. Alright. Okay, let's go to the next question. Find out the value of the current in 3 ohm resistor for the given potential. Okay, listen, let's call this 0 and this will become 50. The potential here is 0. Okay. Now the current that is flowing through this is V is equals to IR. If you put potential difference is 50 divided by 50, it is I. So it is actually divided by 5, I would be 10 amperes. Now the same current would actually go here as well. Okay. But the direction says it goes from positive to negative 10 amperes. So 10 amperes is coming from this way, 10 amperes is coming from this way, and there is no other way for this 10 amperes to go somewhere else. The only way that this is possible is when nothing enters. Understood? So if there is nothing entering, then the current is. So current will just get rerouted like this. The current will stay in these two loops, not going into the third. The distance between two charges, 25 microcoulomb, 36 microcoulomb, is 11 centimeters. Okay, fine. So 25, this is 11. At what point the line joining the two, the intensity becomes 0. Okay, let's call this, let's say it becomes 0 here. Let's call this x, so it will be 11 minus x. We know very well that the field intensity is inversely proportional to square of the distance of that point, isn't it? So I can say, now those should be equal. Only then field here and field here is equal. So E1 equals to E2, understood? So Q by R square. So 25 by x square should be equal to 36 over 11 minus x whole square. And then it is 5 by x, the root over 6 into 11 by x. So it will be 55 minus 5x, that is equal to 6x. So 55 is 11x, x is 5. So it's at a distance of 5 centimeters from 25. Yes. Right? In a cyclic process, initial and the final states are not same. No, wrong. Of course, that's why it's called a cyclic process. Initial and final temperatures are same. Therefore, yeah, this is correct. So statement 1 is false, 2 is true. Next one. If a rigid body is in translational equilibrium, it should be in rotational equilibrium, not necessarily. No. If a rigid body is in rotational equilibrium, should be in translational equilibrium, same way, no. A body in mechanical equilibrium should be in both. Yes, this is right. When a force acting on a body produces a turning effect, the force should be a skew vector. Skew means it's not passing through the axis. That's it. Skew vector has a cross product about the origin. So yeah, this is right. So answer is C and D. Let's go to the next question. A Zener diode of Zener breakdown voltage 10 volts is connected as shown in the figure. The current through the Zener diode. See, whenever there is a xenodiode question, the first thing you should really ask is, will the xenodiode break or not? Now, in this, what we'll do, let's say it is breaking down. If it is breaking down, what is the situation? So this is 500 ohms and this is 1500 ohms. If it really breaks down, the potential difference here must be the Zener voltage 10 volts. Okay, so if that's the case, what is the current here? This current would be 10 by 1500. So it will be 1 by 150. So the current here is 1 by 150. Now that is the case. Let's say if this is 1 by 150. Now let's go around like this. It's 12 volts. If 10 volts is dropping here, 2 volts should drop here. Okay. 2 volts are dropping here. So the current here would be in this stem would be 2 by 500, which is 1 by 250. Okay, the current is 2 by 500, which is 1 by 250. Let's do one thing. Let's make this 2 by 300. This is 2 by 500. Okay, now we can clearly see the current over this particular segment is more than this. There is no other voltage in this case. So there is no way that this is possible. Are you getting it? So if it is breaking down, the current here is more than the current here, which is not possible, which means it won't break. So if the Zener voltage is not breaking, Zener diode is not breaking down, then the current is 0. Right? Let's go ahead. Two vibrating strings of same material of length L and 2L have radii 2I and 2R and R respectively. They are stretched under the same tension. Both the strings vibrate in their fundamental modes. The one of length L with frequency F1 and the other with frequency F2. The ratio F1. Okay, now listen. So frequency is this V by 4L, isn't it? Both fixed. So if you think about it, this will be root over E by mu into 1 by L. So F1 by F2 will expand it a little more, 1 by proportional to 1 by L root over. Tension is also same, it's just 1 by mu, isn't it? Now I want to convert this mu into rho. But what is rho? Mass per volume, mass per area into length. But mass by L is mu, so it will be rho times A. Okay. So it will be 1 by L root over rho times A. So finally, rho is also constant. L2 by L1 into root over A2 by A1. Okay. But A2 by A1 is again R2 square by R1 square. That's it. Okay. So it will be 2 into 1 by 2. 1. So there is, both will produce the sound of same frequency. Okay, in an alpha decay, kinetic energy of the alpha particle, okay, there is a kinetic energy of an alpha particle, okay, which is 48 mega electron volts. The Q value of the reaction is 50. So there is a mother nucleus here. Let's call this as a mass number A, isn't it? Now this guy is giving away one alpha particle. Now this is becoming A minus 4, and this is the alpha particle 4. Okay, that is it. Now, so the kinetic energy in the before, okay, so what do you say here? So this, let's say the kinetic energy is K alpha, okay, so K alpha must be equal to, now the mass number of the parent divided by, okay, mass number not of the parent, of the product, okay. Mass number of the product, which is this, divided by total mass, which is mass number of the parent plus mass number of the alpha particle. Now this should be equal to the Q value. Simple. Okay. So you basically are conserving energy. So K alpha is 48. What is parent mass? Parent mass, product. Okay. Product is A minus 4 by A minus 4 plus 4. It will become 4. Right. A minus 4 plus 4, it will become A. Into Q is 50. That's it. 48 is A minus 4 by A into 50. So what do you get? 48 is 1 minus 4 by A into 50. So what do you get? 48 is 50 minus 200 by A. So 200 by A, that is 200. A is 100. Right? Let's go to the next question. The time period for one oscillation of a long swinging pendulum is determined. The time is to be measured using a handheld stopwatch with a precision of 1/100th of a second. The error percentage is actually 1%. Okay, there is an error of 1%. Every time you measure time, there is an error of 1%. Okay. The time period is known to be 2 seconds. Okay. Which of the following measurement techniques best reduces the uncertainty of the measured value? Because you need a method where the error is very less. See, always whenever there is clearly an error relating to an equipment, and let's say that's the only equipment that you're using. So it's safe to say that the error that you're getting is from the equipment itself. Let's say you want to do 2 to 3 measurements, then you should compare which measurement has more error and then see which one is more sensitive. Okay. Now take a look at this here. So there is only one thing that's measuring. So that is a stop clock. I have to use the stop clock as minimum as possible. Okay. So better take one reading all the time. Okay. So let's see what are the options. Measuring the time for 10 swings and dividing it by 10. This is better because you are measuring for only once. So you are measuring only one time. So there is less error actually. Measuring the time for one swing 10 times. No, this has more error, so it is not. Using a stopwatch that measures with a precision of 1/10. See, 1/10 of a second increases the percentage. Okay, now it becomes 10%. Now, per a second. Is also wrong. Having 10 different people measure the time period and take, no, that's not. Definitely there will be errors. Alright, so the right answer is A. So least number of measurements. Okay, a stick of length L and mass M lies on a smooth table. It rotates an angular velocity of omega to the table, and one of its ends stick to the angular momentum of the stick about the end is okay. So it is a pure rotation. So angular momentum is just I omega. ML square by 3 to omega is ML square by n into omega. So comparison n is 3. Alright. Next question. A meter bridge is a null point at 20 centimeters from one end. The balance is, so there is x and there is 20 centimeters, and then there is, and balance with y, there is another resistance y, it will be 80. So naturally 20 by x is y by 80. So what do you get? X 20 by 80 is x by y. So gone. So 4x equals to y. This is the case. Okay, now next, what are they saying? If x is less than y, yeah, makes sense. Then where will be the new position of the null point for the same end if one decides to balance the resistance 4x against y? So you're putting 4x, and there is one length L, there is y, there is a length 100 minus L. Now come on, this can be directly said. See, I know 4x is equals to y. So naturally these two resistances are equal. If these two resistances are equal, the left length and the right length must be equal. Now, how is that the case, right? It should just be 50. Only then it's exactly at the midpoint. This is the balancing point. This is 50. Alright, let's go to the next question. An open vessel containing water is given a constant acceleration g in the horizontal direction. The free surface of the water gets sloped with the horizontal. Okay, yeah, this one. This angle theta. You know very well, it's tan inverse A by G. Tan inverse A by G meaning tan inverse G by G. It's 1. Tan inverse 1, which is 45. Next question. An unpolarized light of intensity 32 watt per meter square is passed through 4 polarizers as shown whose transmission axes are 45 degrees with respect to next polar. Okay, good. What will be the output intensity in watts per meter square for last polarization? Listen, first of all, it's unpolarized. So 32 would actually first become 16. Now, it would fall by cos square 5. The difference is polarizing angle is theta using Malus law. So what is cos square? It is half, right? So again it becomes half. So it becomes 8, and then it becomes 4. Finally it becomes 2. The answer is 2. Alright? Next question. When a metallic surface is illuminated with a light frequency, okay, we are talking about phi naught plus kinetic energy. Okay, this is the photoelectric equation. So there is 148. Let me see, what does it mean? Okay, I think there is a problem here. I think it should be 8 into 10 to the power 14. So 8 into 10 to the power 14 H is not, plus kinetic energy maximum is 0.5 electron volts. Okay, and then the same surface, which means work function is same. You have 12 4 H is phi naught plus 2. Now they are asking the work function. Simple. Take a ratio. So it will be 8 over 12. It's phi naught plus 0.5 by phi naught plus 2. This is 4 2s and 4 3s. 2 phi naught plus 24 is equal to 3 phi naught. It's 1.5. Isn't it? So it's 0.5, correct? 3 times 0.5, yeah. So phi naught 4 minus 1.5, 2.5. Isn't it? So this 2.5 is equals to 10 by n. So n is 10 by 2.5, 2.5 force. That's 4. Alright, so that's it for today. Thank you.
So first question, if you look at it here, the purple color of KMnO4 is due to charge transfer complex. Okay, charge transfer transition, you can say. Reason here, they have given the intense color in most of the transition metal complexes due to DD transition. See, this DD transition is happening. First of all, I'll explain the reason, then I'll come to the assertion statement part also. Okay, this D and D transition, if I'll going to say, so this DD transition basically happening for the such type of you can say element atoms where half filled D1, or instead of saying half filled, you can say here electron D1 to D9. Okay, electrons present. Okay, but if D0 or D10, D0 is present or D10, then they are colorless. There will be no color. Okay, first condition is clear. So reason is true. Definitely reason is true. Now we'll talk about assertion. So if I'll say assertion part, so in assertion KMnO4, okay, if you look at this, this is plus 7. Plus 7 means it is no d electron, but still it is color. Then there is a some other concept also applicable. And then if you look at it, dichromate potassium K2Cr2 O7 plus 6. This is also, there will no d electron. So they perform color nature due to charge transfer. Okay, so here oxygen, look at it here, Mn is in plus 7. Okay, so when oxygen provide one electron, it will become Mn plus 6. So because of Mn plus 6, it accepts the one electron from oxygen. Oxygen is donating here one electron, so that's why it is accepting that one electron and showing plus 6, and then after that it will show color nature. So this is also correct. So assertion is correct, reason is correct. But here the reason that explaining the assertion, that is not true. Okay, so both A and R true, but R is not the correct explanation. So option B is correct. Okay, now which of the following does not give white precipitate when dilute hydrochloric acid is added? So when we add the dilute hydrochloric acid, basically this one, Ag plus Ba plus 2, Pb plus 2 and Hg2 plus 2. So Ag plus Pb plus 2 plus and Hg2 plus form white precipitate of AgCl, PbCl2 and Hg2Cl2 respectively. But Ba2 plus does not form white precipitate because this one is soluble. This is soluble in water. If it is soluble, so how come it is going to form a precipitate? So that's the reason option B is correct. Okay. Next question. 1 liter mixture of ozone, okay, at STP 1 atm was allowed to react with excess of acidified solution of Ki. Released iodine required 80 ml of M by 20 sodium thiosulfate, okay, for titration. Volume of oxygen in original mixture at STP will be 2 Ki plus H2O plus O3 gives 2 KOPH plus I2 plus O2, and I2 plus 2 Na2S2O3 gives Na2S4O6 plus 2 NaI. So what is the right answer for this question? So for this question, if we will approach So basically here we can say Na2S2O3 used. Okay, Na2S2O3 is used. That is your 80 ml of M by 20. 80 ml of M by 20. Okay, and then further we can say moles of Na2S2O3. Moles of Na2S2O3, that is going to be your 1 by 20 into 0.80. Okay, so when we solve this one now, so we will get 0.004 moles of Na2S2O3. Now moles of I2 also we will get. How? Moles of I2, that is your 0.004 divided by 2, we will get 0.002. Okay, now moles of O3. So moles of ozone, here we will going to solve. So for that it is 0.002, 0.002. And one more thing, since here we can say that 1O3 gives, see here, 1O3 gives 1 I2. 1O3 is giving 1, sorry, I2. Then further, when we proceed for that question, so we will get what? Here, volume of O3 at STP. Volume of O3 at standard temperature pressure, that will become what? That is 0.002 multiply with what? That's multiply with the 22.4. Okay, and after multiplication, so here it will come 44.8 milliliter. Okay, then total gas mixture, it is 1 liter. It is 1 liter total gas mixture, so it is 1000 ml. If it is 1000 milliliter class, then volume of O2 will become what? Volume of O2 is going to be 1000 minus 44.8, and answer is 955.2. 955.2 milliliter. Okay, so this final this one is going to be this one ml. So we can say here right answer 955.2 ml. Okay, clear? Next question. Which of the following is correctly matched? So for correctly matched, if we look at it here, basically in this question, melting point ammonia, NH3, PS3, SH3, SPH3. Okay, hydrogen, and then that nitrogen family element, then hydrogen bond angle, NH3, PS3, SH3, SPH3. That is E is central atom. Okay, boiling point. If you look at it here, NH3, PS3, SH3, SB3, and element and hydrogen distance, ammonia, phosphine, ASH3 and HBH3. So here if you look at it here very carefully, okay, so for this question the correct answer is option, this one, option B. Okay, why other options are not correct, class? So basically if you look at it here, NH3, okay, NH3, PHH3, and then further basically ASH3 and SPH3. Okay, so the right order is basically this NH3. Okay, then after that, because more hydrogen bonding is there, then it is we can say SBH3. PIH3 is also there, but I am, if you want you can write it here before that. SBH3, if you want you can write it BIH3, then SBH3, then ASH3, then it is PHH3. Okay, due to here, why is that happening? Due to hydrogen bonding. Hydrogen bonding more. Now the boiling point order, if you want to write now, so boiling point order is this one. BIH3 is more. Okay, after BIH3, then we have this one, SBH3. Okay, then after that, after BIH3 and after SBH3, then we have NH3. Okay, hydrogen bonding is there, but it is not that much in case of boiling point. Okay, NH3, and then after NH3, then we have ASH3, and least is PH3. Okay, clear? So this is the order of boiling point. Now distance part, if you look at it here, electron hydrogen distance, that is NH3, PS3, SH3, SBH3. So larger the size, larger will be the distance. Okay, between, because crystal lattice is this one and this one, so distance is also, because then nitrogen, if you look at this, nitrogen, phosphorus, arsenic, antimony and bismuth. Nitrogen belongs to your second period. This is third, then fourth, fifth period is, and hydrogen is first. So distance is used now. So this distance is not correct. Option D is also not correct. So that's why option B is appropriate bond angle. Okay, clear? Here bond angle ammonia 107. Phosphine 93, this is 91 arsenic, okay, and this is 91.3 again, and then again it's going to due to the Drago's rule, if you remember. Okay, clear class? Now we'll proceed further to the next question. The correct order of reactive towards nitration using HNO3 H2SO4 mixture, the given compound. So here nitration, basically through this we are doing what? We are doing nitration, that is NO2 group, nitronium ion, this is your nitronium ion will come on benzene. This is basically electrophilic process, electrophilic aromatic substitution process. Okay, so during this, if your more electron donating group is present, they increase. Here if it is, look at this one, so here this first one is electron, CS3 is what? This is electron donating. Okay, so if it is electron donating group, it increases electron density where means on benzene. Okay, and then this one Cl group, basically second one, this is electron withdrawing, it withdraws the electron, so ring deactivate. If ring deactivate, so basically here plus M is also work minus I, but minus I is more dominant. If minus I is more dominant, so that's why I'm saying it is taking out the electron. Electrophilic aromatic substitution very, very less. Okay, so correct order for this one is more, then after one fourth benzene, okay, then 2 and then 3, because 3 Cl groups, right? As option is here in this question, option B. Okay, I hope this part is clear to all of you. Next question, the major product in this reaction. Okay, following this one, so A, B, C, and then D option. Okay, so here if we start solving this question now, so first of all HI will come and it will give you okay. Now here this is the reaction, and on this reaction if HI is work and in heat, I am assuming my HI is in excess. Okay, so here what will happen? Protonation. Okay, protonation will be there, so H will attack here as well as H is going to attack on this side. So then after this we will get O H, and here O H, this one. Okay, plus charge, plus charge. Okay, now after that, so there are two possible conditions of carbocation. What are the two possible conditions of carbocation formation? So first one, if I am removing here this part, I am removing, okay, CS3OH. So after removing this, so we will get the carbocation what? We will get the carbocation like this. Okay, just a second, and this will take. Because it is transferred inside the ring. Okay, and here O H plus charge. Okay, this is more stable carbocation. This is stable carbocation, right? But listen now, if another carbocation, if you want to form another one, so that this below one, it is going to be least stable. Okay, this is going to be least stable. So now at the same time, here what we are going to do at this one, if from here if you remove now, this is going to be less stable carbocation. Now on this part again I minus will attack. If I minus will attack, we will get I. Okay, and here it is O H, this plus charge. Okay, now so again this one, if oxygen will take the electron, so here this CS3 will go and this will I will attack on here, and then after that the final product for this reaction, because iodine inside the solution. Okay, so it will, oxygen will take the electron from this group, oxygen will take the electron, and this CS3 will go, CS3I will form, and this reaction is looks like this way, OH. So this option is matching. No, this one is, D option is matching. Yes, D option is the right answer for this question. Clear how we discussed, how we have done? Okay. Now next for the reaction. Okay. 2A plus B gives you 2D, delta U not 298. This is 2 minus 2.5 kilocalorie, and delta S not 298 temperature. This is minus 10.5 calorie per kilo. Calculate approximate delta G naught. Okay. So for that one, formula delta G naught is equals to delta H naught minus T delta S naught. Okay, class? Clear to all of you? Now, after that, in place of that, we can write delta H formula. Remember delta H enthalpy formula? I am writing it here. That is delta U plus here overall delta PV. Right, everyone? So we can say delta G naught, delta U naught plus this is going to be delta PV minus T delta S. This is going to be delta U naught plus delta PV for, and this one we can calculate delta nRT minus T delta S naught. Okay, so here we will use R because in kilocalorie everything, so R value is 2 calorie per mole kelvins, and delta N value, this is a 2D product side, and this is 3 moles, so 2 minus 3, this is going to be delta N value is going to be minus 1. Okay, so delta N value is minus 1. Now we have to put all the values, so this will directly, if you want to solve this whole thing, so first of all this is minus 1 into 2 into temperature 298. Okay, this is minus 596 calorie. Okay, so now delta G naught, if I'll calculate, this will become what for me? This is going to be minus 2.5 kilocalorie. So calorie minus 200 2500 calorie. Okay, plus minus 596 calorie minus 298, and this is minus 10.5. Okay, so now it is, if you calculate, it will comes here after that overall calculation, that is 33 calorie. Okay, 33 calorie here, it, in terms of that kilocalorie, it will become what? That is 0.33 kilocalorie. Okay, and 0.33 kilocalorie, is there any answer? Yes, option D, and this is non-spontaneous process. Okay, now next question, consider the following carbocation. So for that carbocation stability, C6H5CH2 plus, first C6H5CH2 CH2 plus, and third one C6H5CH CH3 C6H5 C plus and CH3 whole twice. So first of all, the most stable carbocation is because here this is a phenyl group, and here 2 CH3, so hyperconjugation also you can say, or inductive effect. Okay, so more stable. Fourth one is more stable, so wherever fourth is more stable, greater, that we have to take. So means D option we have to discard now. One A, B, C we have to take. Out of that A, B, C, now after fourth, which one we have to take? Then look at the third one. There is again phenyl group, okay, resonance, and CH3 again inductive or hyperconjugation. So after 4, 3. So wherever 4 and 3 is written, then that option we, after 4 then 3, then this is phenyl group resonance, and this is not possible here. Okay, because CH2, so less stable, so that's why option A is most appropriate and correct for this question. Now after this we'll move to the next question. Reason also I explained. Now which of the following compound will behave as what? Which one is going to behave as reducing sugar class? So for reducing sugar, if we have to discuss, so what we can say here, sugar that have free aldehyde, okay, and ketone. Sugars that have free aldehyde, ketone, a hemiacetal, or a hemiketal, okay, group is able to reduce an oxidizing agent. These sugars are classified as reducing sugar. So here option A is correct. Okay, this option A is correct. Basically this one will, an presence of aqueous KOH, okay, O minus will come here, this one. Okay, and then after that we will proceed further. So after this we will move to the, wait a second, this one. Option A is correct. Now next question class, as I said, no. In the reaction, what is the final product? So A option is this, then B, C, and then we have D option. Okay, so now in this question is very simple, NH2, NaNO2, HCl, so diazonium salt diazotization process. First is this D compound is diazotization process. Okay, so here the compound is N2 plus and Cl minus and CH3. After that CuCN and KCN. CuCN and KCN will react. So product is, this is very simple, CN and CH3. So is there any option? Option A is not correct. Option C is correct for this question. Okay, next question. The order of reactivity of phenyl magnesium bromide in with the following phenyl magnesium bromide class. So here basically phenyl magnesium bromide, that is C6H5 MgBr. So this is your nucleophile. Okay, So nucleophile attacks less steric hindrance, where electron nucleophile also attack those areas where electron density less. If electron density is very less, but here if you look at the phenyl, 2 phenyl group, electron density is huge. Okay, so third is order of reactivity is very less for third. Okay, and if you look at this acetone, this one acetone, if you look at it now, so in acetone also 2 methyl groups are there, they showing inductive effect plus, and they increase the electron density on this first one acetone. But if you look at the aldehyde, here only one CH3 group and one side H, electron density is less as compared to 3 and 1. So where the process 2, 1 and 3, option C is correct for this question. Next question, the number of optically active compounds product obtained from the complete ozonolysis. So when we do the ozonolysis, so after ozonolysis, this bond will ozonide will form here, here ozonide form, here and here. Okay, so product the one that we will get for this reaction, basically in this reaction, what is the answer? The answer in this question is 0. Okay, see here, during the ozonolysis we will get first one here, the first compound CH3, C double bond O H, this is a chiral. Okay, then after that the next compound that we will get double bond O, this one here, C double bond O H, C CH3 H, C double bond O H, this is also a chiral. Okay, clear? And then again this one, the same compound you will get here, this one, this is giving you CH3, this is again, this one is a chiral. Okay, this one is again a chiral compound you will get, and the last one is also your a chiral. So I think this part we have done. Okay, clear class? So right answer is option A, that is 0. Next question. This is a very important question. Consider the following plots of a rate constant versus 1 by T for a 4 different reaction. Which of the following order is not correct for the activation energy of these reaction? Which of the following order is correct for the activation energy of this reaction? Okay. So plot is given. So for that plot, let's use this K is equals to A e to the power exponential power minus EA by RT. Okay. Clear? This one. Log K versus 1 by T plot. This one we have to write like this. Now, if I'll take ln both sides, ln K is equals to ln A e to the power minus EA by RT. Okay. Now, if I'll further proceed, so ln A plus ln E minus EA by RT. So ln K will become what when you solve further? So this is going to be ln A minus EA by RT. Take open the ln and use 2.303 log K is equals to this is going to be 2.303 log A minus EA by RT. Further we'll calculate, so log K is equals to log A minus EA upon 2.303 R 1 by T. Okay, so this slope that I will get, that is for me y is equals to C minus mx, and that is negative slope. Okay, slope negative, and for that the order, the one that is greater. So for that C, if you look at it now, for C this is going to be this data, this is for B, this is for D, this one, this value is greater, this value is here for A, this is for C, so this value is greater for C, so EC is greater than EA, this value is very less for B, and then it is D. So EC, EA, ED, BB. So option D is correct for this question. Next, for the cell Zn, if Zn2 plus, Mx plus and Ms different half cell and their standard electrode potential, okay, already mentioned here. So E naught of Zn2 plus zinc minus of 0.76 V, which cathode will give a maximum value of E naught cell per electron transferred. Okay, so for this question, how we have to approach? So basically, students, for this question, we can say Zn plus 2Ag plus, okay, when it reacts, so it gives you 2Ag plus Zn2 plus. Okay, now if you calculate E naught of cell, so E naught of cell formula, E naught of cathode minus E naught of anode, and on cathode reduction, on anode oxidation, right students? So here it is given, this is given your if I'll take a reduction potential as this one, for Ag it will be greater, okay, 0.80, and this is going to be minus minus 0.76. So when we calculate, so it will going to be 1.56 and 1.56 for 2 electrons. But they are asking per electron, right? So for per electron, if you calculate, that will become 1 electron. That is 1.56 divided by 2. So it is coming somewhat 0.78. 0.78, that is through Ag plus. So that's the right answer. Okay. Next. There are 4 elements P, Q, R, and S having atomic number Z minus 1 condition, Z plus 1, and Z plus 2 respectively. If the element Q is an inert gas, select the correct answers from the following. P has the most negative electron enthalpy. Yes, because P is basically explaining halogens. And halogens, they have negative electron gain enthalpy. Yes. So P is correct. And now R is alkali metal. R is plus 1. Where is R? R plus 1. And alkali metals donate only 1 electron. So this is your alkali metal class. Okay. Because if you look at the example of sodium. Okay. So sodium is basically 1s2, 2s2, 2p6 and 3s1. It easily donate 1 electron. So definitely Z plus 1. This is your alkali metal. Okay. Clear? Now then S exists in plus 2 oxidation state. Plus 2 means it is plus 2 like any metal like calcium if I'll take. So it is going to give you 1s2, 2s2, 2p6. Okay. And then this one 3s2, 3p6 and 4s2. Okay. So if released it will become plus 2. So it is exist in plus 2 oxidation state. Okay. So this one is also correct. So here we can say which option is correct. 1, 2 and 3 all are correct. Option D is appropriate for this question. Next, the incorrect statement class. The first ionization enthalpy of potassium is less than that of sodium and lithium. That is true because if you look at lithium, sodium, potassium, rubidium, cesium, top to bottom, ionization enthalpy decreases because number of shells increases. So this one is correct. Now, xenon does not have lowest ionization enthalpy. So helium, for B part I am explaining. Okay, helium, neon, argon, krypton, xenon, radon. After xenon, radon. So they are saying xenon does not have lowest ionization enthalpy. Yes, after that radon is there. Okay, so number of shells again increases, ionization enthalpy decreases. So this is also correct. Now, the first ionization enthalpy of element with atomic number 37 is lower than that of element with atomic number 38. So for that, this one is rubidium, and then if you look beryllium, magnesium, calcium, strontium. So this is 38. So left to right, ionization enthalpy increases. So they are saying first ionization enthalpy of element with atomic number 37 is lower. Yes, cesium, rubidium is lower because alkali metal and alkaline is greater. So 38. So C is also correct. Now the last option is definitely the incorrect option B because the first ionization enthalpy of gallium is higher. How come? Because zinc is there now, and zinc has fully filled and fully filled. If remember half filled and fully filled conditions, they affect the ionization enthalpy. If someone is fully filled or half filled, then ionization enthalpy is higher. Okay. So and that's the reason option D is incorrect. Zinc is greater than gallium is the one. Okay. So this is the answer for this question. Next question class. The equilibrium constant A gives B plus C is first. B plus C gives you P. So A to B. So simple A gives you B plus C. This is K equilibrium 1. And students, B plus C gives you P. This is your K equilibrium 2. And for A to Phi, I have to find then K equilibrium, that is nu K dash, I can imagine. So B and C when we add, so during the addition, equilibrium constant is going to multiply. So option D, K equilibrium 1 into K equilibrium 2. This is the right answer. Next question. 100 ml of 0.1 molar HCl is taken in a beaker and to it 100 ml of 0.1 molar NaOH is added in steps of 2 ml and the pH is continuously measured. Which of the following graphs correctly depicts the change in pH? So students, here first of all what we have to do, we have to look at the graph very carefully. Okay, so when we look at the graph, okay, so this is A, B, C and D. First of all, here in this graph, if you look at it here very carefully, okay, so we can say here titration is happening between what? That is, first of all, we can say titration is going on, titration of 0.1 molar HCl with 0.1 molar HCl with 0.1 molar NaOH. Now, this is the process going on. Okay, so when we starts at pH 1, as NaOH is added, H plus ion neutralize. Okay, increasing pH. Thus, equivalence point occurs at 100 ml of NaOH, pH nearby 7. Beyond this, excess NaOH raises pH sharply, forming a sigmoid titration curve. So that's why option B is correct. Okay, first of all, 0.1 molar titrate with 0.1 molar NaOH. So pH is what? Basically, first pH is 1, initially starts at pH 1. So NaOH is added now. When you are adding the NaOH, so all the NaOH is what? This slowly H plus ions are neutralized. Okay, so please pH is increasing. So pH increasing, but at equivalence point, this is almost pH nearby 7. So if you look at the graph, we are getting pH nearby 7. But as the NaOH increases, okay, so pH is also going to increase now. So we will get sigmoid curve. So option B is correct. Next, this question class, if you look at this question very carefully, okay, so in this question, how we have to radial wave function, okay, for 2s orbital. So basically in this question class, what we have to do, yes, so we can say here radial probability. See, this sigma is known as wave function. This is related to Schrodinger wave equation, wave function, and it does not have any meaning. Basically, psi square has a meaning, mode of psi square has a meaning, that is probability density. It is known as size mode of psi square. Okay, now through this, what we will get, they have given R value A naught, Z value helium, Z value is 2. It's very simple question actually. Okay, so it looks like difficult but very simple. Psi is equals to 2 minus 3 by 2. Z value I can say here helium to 2, A naught 3 by 2, 2 minus Z value 2, R value for me A naught, again here A naught. Wait a second. 2 minus, and this one here e to the power minus, we can say ZR to A naught. Okay, so this value, if you solve this one, I think this value will A naught is cancel, and this one 2 minus 2, so it will become 0. It is 0, so overall equation is 0, I think. Yes, overall equation is going to be 0. Very simple. This question this question looks like a tricky, but this is very simple. Directly it is going to be 0. Next, the conductivity of a saturated aqueous solution of AgCl at 298 Kelvin is found to be 1.38 into 10 power minus 2 ohm inverse meter inverse. The ionic conductance of Ag plus and Cl minus at infinite dilution are 61.9 and 76.3 respectively. Solubility of AgCl we have to find. So for solubility of AgCl, so what we have to do in this question, students, for this question, we can say here K. Conductivity kappa is equals to 1.382 into 10 to the power minus 2. Okay, then we can say this one. It is given in ohm inverse, meter inverse. If we convert in centimeter inverse, centimeter, no, kappa is equals to 1.382 into 10 to the power minus 4. Okay, ohm inverse, centimeter inverse. Okay, now further what we have to say, at molar conductivity at infinite dilution is equals to what? Ag plus and Cl plus. Then 61.9 plus 76.3. Okay, so overall if we add, it will become 138.2. This is 138.2, right? 138.2 ohm inverse centimeter square mole inverse. Ohm inverse centimeter square mole inverse. Now further we have to solve here. This is giving you kappa upon kappa into 1000 upon S. So kappa value is already given, that is and then this one molar conductivity infinite dilution we got. So S value we are going to find it, solubility. So this is S value will going to be kappa into 1000 upon this. So this is 1.382 into 10 to the power minus 4 into 1000 upon 138.2. When we solve this one, so this is somewhat 10 to the power minus 3. It is 10 to the power minus 3 will come. So solubility 1 into 10 power minus 3 mole per liter. So option C is correct, class. Next question. For this question, if you look at it here, that is asking 56 liter of nitrogen gases. Basically, this question is based on two concepts: stoichiometry and Avogadro law. Avogadro law, that volume is directly proportional to N. Okay, if pressure and volume temperature is constant. Clear? So we can say here what? Write the equation first. N2 plus 3H2 gives you 2NH3. Okay, this is your key concept. On that, this numerical is going to proceed. So 1 mole and 3 mole hydrogen gives you 2 moles of ammonia, right? And question is 56 liter of nitrogen gas is mixed with excess of hydrogen gas, and it is found that 20 liter of ammonia gas is produced. The volume of unused nitrogen gas is to be what? Okay, so it's simple. What they have given 56 liter. Okay, this is, I am assuming my excess. So initially this is 0. Okay, so 2 moles ammonia require 3 moles. Okay, so this one 20 liter I can say requires 30 liter. Okay, so this is 1 mole, so this will become what? This is 10 liter. So if you subtract it, this will become what? This is 46 liter. 46 liter is the right answer for this question. Or this question also you can say number of moles of ammonia upon number of moles of hydrogen is equals to volume of ammonia upon volume of hydrogen, directly proportional now. So this is 2 moles, 20 upon volume of hydrogen. This is going to be, when you solve, so it's 16. This is 20 into 3 divided by 2, 10. So this is going to be 30 now. So 30 liter of hydrogen. Similarly for ammonia also, when you solve, and ammonia with nitrogen, so you'll get 46. So 46 is the right answer for this question. Clear, class? Next question. The value of X here, very interesting. Okay, question. So now look at it here. Carbon. This carbon has 2 hydrogen. Okay, so with respect of this carbon, this group, with respect of that, this is acidic. Okay, in nature. So now here if we take NaNH2 now, it's base, strong base. So it will abstract this hydrogen. If it abstract now, so this chlorine will leave its position. When this chlorine will leave its position, so this carbon gets minus charge and this electron transfer here. When this electron transfer here, so structure will be double bond C, Cl, H. Okay. Now further, this is 1 mole first consume. Now NaNH2 again ready, because again acidic hydrogen is present. See here. So this will take, this electron will be here. It will go, and this electron will again transfer here. This electron, this bond pair will transfer here. The Cl will go. So now this is second mole. Okay. So structure will looks like C, triple bond C, H. Okay, second mole. Now third mole also going to use, because this is again acidic hydrogen. This is again acidic hydrogen in triple bond. Okay, so NaNH2 will come and attack. So this time this reaction will be C, Na, and now after that CH3MgBr. So Na will go and CH3 will attack. So finally reaction is looks like C, triple bond C and CH3. So that's why total 3 moles. 3 moles is going to be used in this reaction. Okay, done, class. This one. Next question. How many of the following can exhibit the geometrical isomerism? So if you look at it here very carefully, I'll draw the structures. First one, that is CO, Cl. This is cis form. Okay, En, 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 and it's trans. If I want to draw Cl, Cl, En, En, this one. So this is trans, this is cis. This will show. Okay. Second structure, if you look at this one, so this is chromium, Cl, Cl, oxalate, oxalate. This is cis form. It's chromium, Cl, Cl, OX, OX. This will also show. And this is, if you look at this one, Fe, third one, I am doing it here. Fe, okay. This is going to be like OH, OH, OH2, 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 and here OH2. This is your cis form. Transform if you want, opposite side. Opposite side Fe, OH, OH, rest, OH2, 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 OH2. This is transform. This will also show. And Fe, NH3 twice CN4 minus. This will also show. CON2, this one just now I have mentioned in place of NH3Cl, just this one NH3, this is Cl, and if you NH3 and Cl opposite side, this will also perform. This will also perform. H2Cl position one cis side, and this one, and opposite side it will become this one. So total 6 is the right answer for this question. Okay. Next one, 50 gram ethylene glycol is dissolved. Okay, here 50 gram ethylene glycol is dissolved in 173.3 gram of water and is cooled to minus 9.3 degrees Celsius. The amount of water in grams separated as ice. Okay, so see, weight of solute, that is 50 gram. Okay, now solvent, that is 170.3 gram. Okay, delta TF is basically minus 9.3 degrees Celsius. Okay, so ice amount of ice, this is going to be separated. Okay, we have to find out. Okay, formula that you know that this is based on the solution chapter colligative property. Okay, depression in freezing point, TF is equals to KF into M, molality. Okay, now so this is 9.3 given, 9.3 plus. Okay, let me solve here. This is given 9.3 is equals to KF value is given 1.86 into what we have to write here, 50 upon 62. Okay, 50 gram ethylene glycol molar mass na CH2OH and CH2OH. So this is going to be 24 and then 16 32 30, so 60, no 24, just a second, sorry, 24, and this is going to be 32, 56 and 2 to 4 5 6, 62 is okay, molar mass of ethylene glycol into 1000 upon weight of solvent. Okay, so when we solve this now, so we will get what, 1.86 into 50 into 1000 upon 9.3 into 60 into this one. So students, when we proceed for that, we will get what, this is going to 62 into 9.3, 9 point, just a second, this is 62 into 9.3, and when we solve this one, so now we have to solve, so we will get somewhat nearby value 161, 160, and nearby value we will get 161.3. Okay, 161.3 we will get after that. Okay, so now after 161.3 value that we will get, so now this is amount of ice separated. So amount of ice separated, that is 170.3 minus 161.2, this will become what, this is going to 9.1, so 9.1, and here we will get 9 gram. Okay, in short we can say this is 9.1, so 9 grams is the right answer. 9 gram is the right answer for this question. Next question, amongst the following the number of species with only 2 lone pair of electrons. So 2 lone pair, draw the structures SF6, fluorine, and fluorine. No lone pair, so XeF4, fluorine, 2 lone pairs, so this one we have to count. Meet CF4, no lone pair, and now water, 2 lone pairs, so XeF4 and H2O, so right answer is 2. Okay, clear class? So this part we have done, so that's it for this test discussion. I hope every question is clear to you. Thank you. Good day.
Hello everyone. How are you guys? I hope you guys are having an amazing day, and I hope all of you have given the FT-11 test as well. We're going to be just quickly discussing this test in today's session. We'll be going through all the questions and try to help you guys with any doubts or any problems that you might have faced. Okay, so yes, let's look at the very first question over here. What do we have? So 3 numbers A, B, and C whose sum are 26 form a GP. So GP means we'll, as always, assume the GP in the general form A upon R, A, AR. And you have been told that their sum is equal to 26 is given to you. Okay, A by R plus A plus AR, this sum is given to you as equal to 26. And now what is being told, you have been told that if you add 1 to the first term, 6 to the second term, and if you add 3 to the third term, then the resultant sequence becomes a AP over here. That means twice the middle term, that is 2 times A plus 6 will be equal to the first term, that is A by R plus 1, plus the third term, which is A by R, AR plus 3 wala format over here. Okay. Now here I have the fact that A by R plus A plus AR ka value, I have it as equal to 26. We need to somehow think about using that. And what I can do is over here, this A by R plus AR, can I replace that as 26 minus A? 26 minus A plus 4, this is equal to 2A plus 12. Why does this help out? This helps us because now I can say that 3A jo hai, that is equal to 30 minus 12, that is 18, giving me A equals to 6. The moment I've got A equal to 6, my question is finished then and there itself. Why? Because now I can say that 6, if I substitute A ka value, so one of the 6 will get cancelled out. So I get 3 plus 3R plus 3R square is equal to 13R r over here. This is 3r square minus 10r plus 3 equals to 0. And factorize this as 3r minus 1 into r minus 3 equals to 0. Because the common ratio over here, I have a is greater than b is greater than c. So I will say that the value is actually decreasing, right? So I will take the common ratio as equal to 1 by 3 over here, which would mean that the first term a by r ka value jo hai, that is equal to 6 divided by 1 by 3. That's 6 into 3, 18. Option B will be the answer for the question. Okay? So option B will be the answer for this question. Moving on, let's have a look at the next one. What do we have over here? So we have been told that consider a branch of hyperbola, half part of the hyperbola, with the vertex at the point A, and B is the end point of the latest rectum, and C is the focus of the hyperbola nearest to this point A. Then what is the area of this triangle ABC? So it's a very straightforward question. So first things first, what we have to do is we need to convert this into the standard form of hyperbola, right? So I have x square, I have a minus 2 root x, then I have a minus 2y square, and let me take that minus 2 outside only, minus 2 times y square plus 2 root 2y, and let me put the 6 over to the right side. Okay, so this is the format that I have nearly. So now what I need to do is, how will I complete the square is what I will take. So first of all, x square ke liye to complete the square, I have minus 2 root 2, so I can say that then I need a plus root 2 ka whole square. So basically I will add a 2 on both sides. Over here I need again root 2 ka whole square, that's plus 2, but because I've added 2 over here, indirectly what I've done is I've subtracted 4 over here, so I'll have to subtract 4 over here as well. So what do I have? I have x minus root 2 ka whole square minus 2 times y plus root 2 ka whole square is equal to 6, that's 4. So that's x minus root 2 the whole square upon 4 minus y plus root 2 minus y plus root 2 the whole square upon 2 equals to 1 over here. So now the question is, so you have the hyperbola. Now we have our hyperbola over here. The center is root 2 comma, but we don't really care a lot about the center, right? So all that we care about is that whatever the vertex over here will be, so this vertex A point you have, nearest focus is C over here, and focus ke upar we have your latest rectum over here. Now what I want is I need to find this area over here. Can I say that this distance jo hai between the center and the foci over here, that is equal to nothing but A distance over here, and this distance over here between the center and the vertex, I can say that this is simply equal to A itself over here. Okay, so first of all, what is the eccentricity over here? So I can say that the eccentricity over here for this hyperbola will be equal to root of 1 plus b by a ka format over here. This is my eccentricity. So what is my eccentricity coming out as? So eccentricity will be equal to root 6 by 2. So what is A ka value? A is 2. So A is equal to root 6. And what is A? A is equal to 2. So can I say that the distance between the vertex and the focus jo hai, that is root 6 minus 2. That is root 6 minus 2 multiplied by the height, which is b square upon A, latest rectum, right? That's b square upon A, which is equal to b square, that is 4 divided by 4, that is 1, multiplied by half. This is the area of this triangle over here. What is this? I can write this as 1 root 6 upon 2, that's root 3 by root 2. So whole root of 3 by 2 minus 1. Option B will be the answer for this question. Okay? A very simple basic question over here. Okay? I hope the idea is clear. Righty. Chalo. Moving on. Let's have a look at the root 3 by 2 minus 1. Okay, what do we have now? You have a function f of x is equal to minus 1 when x is negative. All right, it's equal to 0 when x is equal to 0, and the function is g of x f sin x plus cos x, and you have f of g of x. So what I will do is I will look at the basic graph of sin x plus cos x. So I hope you guys have a basic idea about the graph of sin x plus cos x. If not, I'll quickly draw it out for you. 2 pi over here. No, between 0 to 2 pi, the question is, I know that at x equals to 0, what I will have is basically this value is equal to 1. We know that sin x plus cos x attains its maximum value when it attains the maximum value at pi by 4, basically. But both of them are equal to 1 by root 2, 1 by root 2. So it will reach its maximum value somewhere over here at pi by 4. Here it will reach its maximum value, and then it will start dropping down. At at pi by 2, again it is equal to 1. Then again it will keep on dropping. It will keep on dropping just in the same fashion. At this point, 3 pi by 4 jo hai, where now my sine is plus 1 by root 2, but cos is minus 1 by root 2. I attain the value 0. Then the value again keeps on dropping. When at pi, you will reach minus 1, where sine is 0, but cos is equal to minus 1 over here. And then it reaches the minimum value, then it reaches the smallest possible value over here, which comes at pi plus pi by 4, 5 pi by 4 at minus 1 by root 2, minus root 2, minus 1 by root 2, minus 1 by root 2. It reaches its minimum possible value, and then it starts flowing its way back. Then it starts coming up and up and up, and at 2 pi it will again reach the value of, and at 2 pi it will again reach the value of 1 over here. Okay. After that, what happens, we don't really care. Now देखो, can I see over here that if my f of x function, basically signum function, so it only cares about whether the value is positive, negative, or 0. Between 0 to this 3 pi by 4, my function is positive, so f of g of x will be 1. At 3 pi by 4 it will become 0. Between 3 pi by 4 to this 0.7 pi by 4 over here, now it will become negative. And then at 7 pi by, after 7 pi by 4, again it will become positive over here. So basically 3 pi by 4 and 7 pi by 4 will be the 2 points where your function is going to be discontinuous. These are the 2 points where your function will be discontinuous over here. Hence the answer for this question, option B right here. Okay, therefore we can say that option B will be the answer for this question. Okay, plain and simple basics of question. All right, let's move on. What we have over here, we have A and B are two square matrices which are satisfying this condition, AB equals to A, BA equals to B. Then what is A power 2019 plus B power 2019 whole power 2020? Okay, so what I can do over here is, if AB is given to me as A, can I say that AB into A jo hai, that is equal to A into A. And now I can say over here that this AB wala part jo hai, over here I have A square, over here BA I can replace as B, and I can write this as AB, which is nothing but A. So this means A cube, which is equal to A square, is again equal to A. So I can say that any power of A is equal to simply A. And by symmetry, I can also say that same logic will apply for B also. Any power of B will also be equal to B. Because if you look at the two cases, it's exactly symmetrical condition which is given. So B power n will also be equal to B. What I can also just show it to you quickly. If you multiply B on both the sides, AB jo hai, that is equal to A. So you have BA equals to B square, which gives you B equals to B square. That's any power wala B will be equal to B only. So the question now reduces down to what? A plus B power 2020. Oh, now it's still not done. Still have to, now we have to talk about what will happen when you have A plus B power 2020. Let's, again in this case also we are going to get most probably some general result. Let's try A plus B ka square first of all. This is A square plus B square. Don't write 2AB, it is AB plus BA. Now what is A square? A square is equal to A. What is B square? B square is equal to B. What is AB? AB is equal to A. And what is BA? BA is equal to B. So this is equal to 2 times A plus B. What is it equal to? I can say that this is equal to 2 times A plus B wala expression over here. My A plus B the whole square I can say will be such expression. Now if I talk about A plus B ka cube, A plus B ka cube will be 2 times A plus B into A plus B. A plus B ka square into this side. So this is 2 times A plus B ka square. What is A plus B ka square? That's 2AB. That will be 2 square into A plus B. Now I can see a pattern. Next, when we talk about A plus B power 4, what will happen with A plus B power 4? This will become 2 cube into A plus B. So as a general result, I can say that over here, as I have 2020 power, this will be equal to 2 power 2019 into A plus B. What will this be? It will be 2 power 2019 into A plus B. Do we have an option? Yes. Option C will be the answer for this question. Okay? Plain and simple basic over here. All right. So moving on. Let's have a look at the next one. We have alpha is the root of this equation. Okay? If alpha is the root, it means alpha will satisfy. Alpha square minus alpha plus 2 will be equal to 0. Now let's simplify this a bit. I can take first of all alpha common, minus alpha common. I'll get alpha square minus 2 alpha plus 1. Denominator I can take alpha square common. I'll get alpha cube minus 3 alpha square plus 3 alpha plus minus 1. So this is minus 6 alpha into, this is alpha minus 1 ka whole square. Divided by alpha square into, this is alpha minus 1 ka whole cube. I can cancel. So what am I left with? I'm left with minus 6 upon alpha square minus alpha. What is alpha square minus alpha? That's equal to minus 2. Substitute. So that's minus 6 upon minus 2. This is a pure algebra wala question. Okay? This is a absolutely pure algebra wala question. No logic, no any pure identities ka question. Okay? Pure mathematical identities ka question. This one. Hope the idea is clear, everybody. Moving on. What we have now, find the number of 4-digit numbers of the form ABCD which satisfy these 3 conditions. N lies between 4000 and 6000, it's a multiple of 5. And BC, B is smaller than C and they lie between 3 and 6. Okay. So let's talk about ABC. A pe how many options do I have? I can have 4 or 5. I cannot have 6 because then 6,000 is not possible, and anything bigger than 6,000 it is not allowed over here. So for A I only have 2 options. For D I can take 0 or 5, so I have 2 options over here, 2 options over here. Now all I need to think about is B and C. So the condition is that B should be greater than or equal to 3 and it has to be less than C, and C should be less than or equal to 6. So I will literally just write down the possibilities. So I can have 3 4, I can have 3 5, I can have 3 6, I can have 4 5, I can have 4 6, and I can have 5 6. So these are the 6 total possibilities for the combined BC. So 2 into 6 into 2, that's 24 total possibilities I will have. Option C being the answer for the question. Okay, everyone? Hope the idea is clear. Moving on. What do we have now? Okay, so we have some functions. What are the functions? We have x square. So here we go. Here's x square. Then you have 1 minus x square, basically x minus 1 ka square. X minus 1 ka square is simply shifting this x square wala graph 1 unit to the right, just shifting it 1 unit to the right. And then what you have? Then you have 2x minus 2x square wala graph, right? So their midpoint over here is 1 by 2. At 1 by 2, these two are equal to 1 upon 4. And here also this function will also have its midpoint. It has the roots at 0 and 1. So this also will have its midpoint at 1 by 2. But 1 by 2, what is the value? It is 1 minus 1 by 2. That's actually equal to 1 by 2 over here. So this value is a bit bigger compared to the other two terms over here. Okay, so basically I will have my graph of 2x minus 2x square looks something like this. Now we have been told that maximum of these three ka graph area I need to find between 0 to 1. So if I draw the maximum wala part of these three, so what is the maximum wala part if I remove the rest of the part out? So here the maximum bit for a really long time is the function 1 minus x square. After that the bigger function becomes 2x into x minus 1, and then finally the bigger function becomes the x square. Then finally the bigger function becomes the function x square over here. So basically this is what my graph is gonna overall look like over here. This is what my graph will look like at this point. So these 2 points of intersections you have to find. So just substitute over here, substitute x square. So if you do x square equals to 2x minus 2x square wala part over here, what will you get? You'll get 3x square is equal to 2x, and this will give you x ka value as 2 by 3 over here. So this is 2 by 3, and by symmetry I can say that over here I will get the point 1 by 3. So now we need to find this area over here. This is the overall area in question. I can say that what is this area? It is integral 0 to 1 by 3. First you have the graph 1 minus x ka square, or I can write it as x minus 1 the whole square. Then from 1 by 3 to 2 by 3, the bigger curve is 2x minus 2x square. And then finally from 2 by 3 to 1, my bigger curve is x square. So this is the three integrals these are the three integrals that you have. Find the three of them and their addition gives you the answer. So it looks something like this. 1 minus x whole square from 0 to 1 by 3 plus 1 by 3 to 2 by 3, 2x into 1 minus x square, and 2 by 3 to 1 x square. Overall area comes as 17 by 27. Because we have been asked to find it in the format of a by 24, so the 17 by 27 I can write it as 34 upon 54. Therefore the value of a will be option D, 34 over here. Okay, last bit, I hope you're able to do it. It's simply basic algebraic integral of the easiest form. Okay, so moving on. What do we have now? So the points alpha by 2, sorry, 11 by 2 comma alpha lie on or inside the triangles with these following sides. Okay. So this is again a geometry wala question. We will need to draw region. So first line is x plus y equals to 11. So x plus y equals to 11 looks something like this. There's one 11, there's another 11, and this right here is x plus y equals to 11. Very well. Next line is x plus 2y equal to 16. So here you have 16 comma 0. So 16 comma 0 lies somewhere over here, and then you have 8 comma 0. 8 will be slightly below over here. So this is the second graph that we have, second line rather that we have. Cool. And then finally 2x plus 3y, not a good one, right? So 2x plus 3y equals to 29. So over here when you put y equal to 0, you will get x as 29 by 2, which is 14.5. So 14.5 lies slightly less than 16.5. And then when you put y equals to 0, when you put x equals to 0, you get y as 20 Y you will get as 28 by 3. That's slightly bigger than 9 but less than 2, so 9.6k around, so somewhere over here it will lie. So when I draw this line, it will look somewhat like this. Now you have been told that there's a point, this 11 by 2, right? It lies somewhere over here. This 11 by 2 jo hai, it is, x coordinate is fixed as 11 by 2. Now the question is, what are the maximum and the minimum value of y coordinate possible over here? Basically I need to find these 2 points of intersection over here. You can find the third wale ka point of intersection as well, but I can tell you it is going to be less. It is going to come outside the triangle which we are forming over here. So 11 by 2 pe I know that x plus y equal to 11 ke liye, so this point is directly 11 by 2 comma 11 by 2, and for this 2x plus 3y, let's put x is equal to 11 by 2. What will you get? 11 plus 3y equals to 29. Y comes out as y comes as 6. That's a good value. So you have 11 by 2 comma 6. So what are the maximum and minimum value of alpha? 6 and 11 by 2. Therefore what are we looking for? 6 into 11 by 2, that's 33. Do we have an option? Yes, option C, 33 will be the answer for this question. Okay, plain and simple basics question. Okay, pure geometry question. Draw the graph, you'll be able to plot the points required. Okay, what do we have here? You have been given f is a differentiable function defined from 0 to 1 such that, okay, f of x is equal to x. F of 0 is given to you as 1. So if f of 0 is given to us as 1, I can find definitely one thing. I can say over here that f of 0 jo hai, that is equal to 0, which means f of 1 is equal to f of 1 is 0. This is one information we have. Cool. ठीक है. Now f of x is equal to x, somehow we need to use this concept over here, right? So let's go for a substitution of x is equal to f of t. That would mean that dx will become replaced with f dash of t dt. So I'll get integral f of t minus what is f of t? That will become t whole power 2018 into f dash of t dt. What will be the limits? So over here, think about this. I get two values over here. When x is 0, t is 1. When t is 0, x is 1. They're just reciprocating, right? So the limits will become interchange 1 to 0 over here. This is the format that you will get over here. Now, now we compare the two expressions over here, and I can see that I can slightly write this by switching the limits. Minus of 0 to 1, t minus f of t. Let's replace with x. X minus f of x power 2018 into f dash of x dx. I've not substituted, guys. I've replaced. So if it is t or if it is x, it doesn't matter. I've completely replaced. And now, if you add the original integral and this modified integral that we have, what you're gonna get is 2 times integral is integral 0 to 1. This x minus f of x power 2018 is common in both the cases. So x minus f of x power 2018 common. I'll take it common from both the cases, and I'll get 1 minus f dash of x dx. Why is this important? Because this 1 minus f of x 1 minus f dash of x jo hai, that is the derivative of x minus f of x wala term over here. So that means I directly have my derivative present over here. So my integral will be x minus f of x whole power 2019 divided by 2019, limit from 0 to 1 over here. Limit from 0 to 1 over here. Okay, this is what you're looking for. So when you put in 1, so you'll get 1 minus f of 1 power 2, that's 0, 1 upon 2019, minus you have 0 minus f of 1, that's minus 1 power 2019 divided by 2019, that's equal to 2 upon 2019. This is your 2 times integral. Cancel. Integral is 1 upon 2019. What's asked in the question? P plus Q ka value, that's 2020. Option C should be the answer. And yes, that is the answer. Option C over here for this question. Okay, everyone? Hope the idea is clear. Little bit of basic manipulation wala funda tha over here. Okay, moving on. Right, what do we have here? You have 2xy plus x square y plus y cube upon 3 dx plus x square plus y square dy equals to 0. Y of 1 is given to you as 1. What is the value of y of 0, the whole cube? If it is k, what's k? Cool. First of all, let's open this up a little bit. 2xy dx plus x square y dx plus y cube upon 3 dx plus x square dy plus y square dy equals to 0. Okay, let's see some similarities, some terms that we can use. Can we get anything over here? One thing that I can see directly over here is this is x square dy and 2x, which is the derivative of x square 2x dx into y. So I can say that that's nothing but x square y ka derivative. Plus I also have a x square y into dx. That's good. Then over here I have y cube by 3 dx, and this right here is nothing but the derivative of y cube by 3. This is y square is nothing but the derivative of y cube by 3. Some similarity I can form. So I've used that. Acha, now over here, can I write this as derivative of x square y plus derivative of y cube by 3 is equal to minus of x square y plus y cube upon 3 dx. And if I send this over to the denominator, derivative of x square y plus derivative of y cube by 3 upon x square y plus y cube by 3, isn't this directly integrable, giving us ln x square y plus y cube by 3 is equal to minus x, that's minus 1, sorry, minus x plus the constant of integration. Now what do you have to use? You have been told y of 1 is equal to 1. So substitute x is equal to y equals to 1. That will give you ln mod 4 by 3, ln 4 by 3 equals to minus 1 plus c. So I can say that c jo hai, that is equal to ln 4 by 3 plus 1 over here. So I got this as the value of c over here. Now what do we have to find? We have to find the value of y at x is equal to 0. So let's put x is equal to 0. So what will you get? You will get ln y cube by 3 is equal to minus 0 plus ln 4 by 3 plus 1. So ln 4 by 3 plus 1 ko can I write 1 ke jagah ln e, which gives me y cube by 3 is equal to 4e by 3. So y cube comes out as 4e. I think this is exactly what they were asking for. Y ka value 4e. So k will be equal to 4 over here. So k will be equal to 4. 4 should be the answer for the question. Option B, 4 is the answer over here. Okay? So this was a little bit of a exact form of differential equation ka logic that you have to use. You have to convert this into the exact form, use all the fundas that you could to manipulate it out, and hence finally getting the answer over here. Okay? Chalo, moving on. What do we have here? So you have f of x, which is cos inverse of root log x to the base 4 minus pi by 2 plus sin inverse. Achha, now over here there's a very interesting funda that's happening. Though can I say over here cos inverse ke andar there is only positive value, which means cos inverse lies between 0 to pi by 2, and as over here my cos inverse is lying between 0 to pi by 2 over here, and the upper limit, and there is minus pi by 2, and that entire term is present inside the root. So the only acceptable value that we have is cos inverse log x to the base 4 is equal to pi by 2. This is the only acceptable value that you have, which means log x to the base 4 has to be 0, which means x has to be equal to 1. Because for any other value, you will get something less than pi by 2. A value less than pi by 2 minus pi by 2 gives you negative value ka root. That's not allowed. So you have x is equal to 1 over here. So when you substitute, you will get 0 plus sine inverse of 2 by 4. That's sine inverse 1 by 2, which is pi by 6. Therefore, option D will be the answer for this question. Okay? And interesting, but quite an easy question, I would say. Sure. Moving on. Okay, two loaded dice, basically manipulated dice, biased dice, have the property that 2 or 4 is 3 times as likely as 1, 3, 5, 6 on each row. Okay? So if 2 and 4 ka probability is some x, 1, 3, 5, 6 ka probability is x, then they are telling that 2, 3, 4 ka probability is 3x. So total probability has to be equal to 1. So x will be 1 by 10. So that means probability of 2, 4 is 3 by 10, 3 by 10, and over here it is 1 by 10, 1 by 10, 1 by 10, and 1 by 10. Now we have been asked to find what is the probability of rolling a 7. How many ways can I roll a 7? So I can either have 1, 6, 6, 1. So basically I'll take 2 cases here. Similarly 2, 5, 3, 4. All of them, there are 2 cases possible. 1, 6 ke liye, what is the probability of drawing a 1? That's 1 by 10. What is the probability of drawing a 6? That's 1 by 10. I'll multiply by 2. Why? Because 1, 6 and 6, 1 is also possible. Similarly for 2, 5, what can we do? We can do 3 by 10 into 5 is 1 by 10 into again 2, because I can also take 5 comma 2. Similarly over here 3, 4 may also, I have 3 is 1 by 10, I have 4 is 3 by 10 times 2. Adding all of this, what do you have? 2 plus 6 plus 6, that's 14 by 100, which is nothing but 7 by 50. That should be option C. That's option C, the answer for this question. Basic manipulation wala from that. Okay. Chalo, moving on. What do we have? we have an f of x square into sine 1 by x plus 2x upon 1 plus x power 1 by x minus e over 1 plus x power 1 by x wala manipulation. So there's a standard limit, which standard idea that you should rather know. I'll just give you a quick idea. So there's an expansion for 1 plus x power 1 by x. The idea here is, I don't really have a direct expansion for this, but I can take e power ln of 1 plus x power 1 by x, and I can take this 1 by x outside and write it as e power 1 upon x into ln 1 plus x. Now this is e power 1 by x into ln 1 plus x का expansion क्या होता है, x minus x square by 2 plus x cube by 3 and so on and so forth, which now becomes e power 1 minus x by 2 plus x square by 3 and so on and so forth, which I can write it as e multiplied by e power minus x by 2 multiplied by e power x square by 2 multiplied by e power minus x cube by 4 and so on and so forth, which further then I can use the e ka expansion extending to 0 obviously, and wherein further I can use the expansion series of e with the format of 1 minus x by 2 plus minus x by 2 ka whole square by 4 and so on and so forth. I can use the entire expression plus minus x by 2 plus minus x by 2 ka square upon 2 factorial and so on and so forth. Same with x square by 3 also, same with x square, and this keeps on going till infinity. And the idea behind all of this is, after simplifying this out, what you actually get is a standard result, which you should remember. You can directly remember it is e into 1 minus x by 2 and 11x square by 24. These are the only two terms that you have to remember. Higher powers, x cube and everything, we don't really use it much often, so you can just kind of leave that out over here. So this is the part which is important, which you have to remember over here. So now, what is the use of this expansion series over here? In this question, if you look at this, you have sine square x into sine 1 by x plus 2x divided by, if I use this expansion series, what do I get? I get e minus ex upon 2 plus 11ex square upon 24. The remaining terms are there. Minus e plus e I can cancel. We can also cancel one of the x out from the numerator and from the denominator. So what will I get? I'll get x into sine 1 by x plus 2 divided by, you have minus e by 2 plus 11e x by 24 and so on and so forth. Now all of these terms, I'm going to create a 0, and as I've got an extra minus e by 2, I'm happy with this. This term also 0 into some sign of infinity, which is still sign lies between minus 1 to 1, that's again 0. So what I'm left off with is simply 2 upon minus e by 2, which is minus 4 upon e. Yes, option D, minus 4 upon e will be the answer over here. Okay, everyone, hope the idea is clear. Yeah, so you can use that standard limit directly, 1x power 1 by x, you can remember it, or you can actually kind of simplify and get that term over here as well, which will be a bit more of a tedious task if you ask me. All right, moving on, let's have a look at the next question. So the equation of two adjacent sides of parallel array. This is one of the most simplest type of question that you can get. So you have been given two sides of a parallelogram. What are the two sides that are given to you? One side is 2x minus 3y equals to minus 23. Another side is 5x plus 4y equals to 23. First of all, we need to get their point of intersection. If you add them, you will get what? 7x minus y, 7x plus y equals to 0. So that 7x is equal to minus y. And from there, you can manipulate it out and you will get what? Minus 1 and 7, right? Minus 1 comma 7, is it satisfying both of them? Minus 2, minus 21, yeah. Minus 1 comma 7 will be their point of intersection. Now the other diagonal, the one diagonal which is given to you, 3x plus 7y equals to 23. Is it satisfying minus 1 comma 7? I can see over here that minus 3 plus 49, it's not satisfying. So that means this is the diagonal in question. This is the diagonal in question which does not pass through minus 1 comma 7. So now you need to find what? The other diagonal equation we'll need to get, and then we need to find the distance of the other diagonal from the point A. Okay. Other diagonal ka distance I need to find from the point A over here. So for this, I'll need to now, first of all, solve 3x plus 4y equal to 23 and 5x plus 4y equals to 23 together. And I think you will get 3, 2 over here as their point of intersection. And C ka coordinate jo hai, to solve this 2x minus 3y minus 23 and 3x over here, 4, 5x plus 4 is equal to 0 wala format you will get, and minus 4 comma 5 should satisfy over here. So minus 4 comma 5 is the point of intersection. Now what is the midpoint of the two of them where the two diagonals meet? So 4 minus 3 by 2, that's minus 1 by 2 comma 2 plus 5 by 2, that's 7 by 2. Actually, looking at this, can I also directly say that this other point over here will be 0, 0? Because minus 1 by 2, 7 by 2 is directly half of minus 1 comma 7. So I have a point which is passing through minus 1 comma 7 over here and 0 comma 0. I can directly say that the equation of this line will be y equals to minus 7x. No? Or I can say 7x plus y equals to 0. Now I need to find the distance of 3 comma 2. So that will be what? 21 plus 2 divided by root of 50. So this is the distance. Achha, what we have to find is 50 into d square. So that's 50 into 23 square upon 50. That's 23 square. There's only one option ending with 9. You don't even have to find the exact value. You can say 529 will be the answer for the question. Okay, hope the idea is clear, everyone. Sure. Moving on. Okay, a survey of 500 television watchers produced the following information. 285 watch football, 195 watch hockey, 100. This is a very standard type of question. Let's draw the 3 sets wala Venn diagram. Those of you who don't watch any game is 50. Let's keep them outside. Let's assume that X number of people watch all 3 games. So what all games do we have? We have football, hockey, and basketball over here. Okay. So now we go one by one. So 50 people watch hockey and basketball. Hockey and basketball, 50 people. So there's already X. So in this specific region, it will be 50 minus X. Then you have 70 people watching football and hockey. So that's 70 minus X. Then you have 45 people watching hockey and basketball. So here I will have 45 minus X. Very well. Now you have been told that total 115 people watch basketball. So basketball ka total region has to be 115. How much do I already have? 95. So that means I needed 20. And then I also need a plus X over here. So 20 plus X are the people who are watching only basketball. Then only football, what do I have? Total football watchers is 285. I already have 115 over here. So that's 170 plus X. Then total number of hockey watchers is 195. We have 120 people who are watching, 120 already over here, 95. So that's 75 plus X, which is required. Achha, now if you look at this, the people who are watching exactly one game. So that's 170, 190 plus 75, 265. So I already have, na? So the only option which is more than 265 is option D, 325. The only option which is more than 265 is option D, 325. Directly 325 will be the answer. I don't even have to find X. You can actually get X also. So what can I say? The entire football wala region jo hai, that is 285. So 285 plus this minus X plus X will be cancelled out. So you have 20, that's 70 plus 145 plus X plus 50 equals to 500. Okay, this is the expression that you have. You can say, what do you have over here? 230. And that will give you a value of X as some 20. I believe should get the value of X as equal to some 20 over here, right? That's 420. Now 430. 430 plus 50, 480 plus X is equal to 500. X will come out as 20. So, but not really needed. We're looking at the options. Only option D is the one which is gonna satisfy, as the overall sum comes as 265 plus 3X. At 265 plus 60, 325. We can also verify the answer. Alright, so pure Venn diagram question, nothing else. Okay, moving on. The coefficient of x power minus 2 and x power minus 4 in this expansion. Okay, what does the general term look like? General term is 18CR into x power 18 minus r by 3 into 1 by 2 power r into x power minus r by 3 into x power minus r by 3 ka format is what you have. So over here, can I say that my combined power of x jo hai, that is x power 18 minus 2r divided by 3. I will put this as equal to minus 2. Then what will my r ka value be? R will be minus 6 I need, so 12. When I put minus 2r by 3, when I put this as equal to minus 4, what will r be? I need 12. So 12 will be given by 18 minus 30. So that's 15. So r is equal to 15. Now the coefficients are said to be in the ratio m is to n. So x power minus 2 ka coefficient jo hai, I will substitute r as 18. So I'll get 18 factorial upon 12 factorial into 6 factorial multiplied by 1 by 2 power 12 divided by, when you substitute r is equal to 15, you will get 18 factorial upon 15 factorial into 3 factorial into 1 by 2 power 15 over here. So cancels out. You have 1 by 8. 18 factorial, you can cancel it out. This you can cancel it out, leaving you out with 15, 14, 13. This you can cancel it out, leaving you out with 6, 5, 4. I can cancel this over here. I'll get a 3 left out. Then I can cancel this 6 and over here 3, and this 7 I can cancel one out over here. and this 4 and this 8 I can cancel it out as 2. So what are we left with? I'm left with the value over here, this 2 into 7 into 13, that's 14 times 13, which is equal to 182. Yeah, 140, 42, 182. 182 should be the value of m by n. 182 will be the final value of m by n. Pure calculation. It's a pure just cancelling out all the terms and simplifying the expression that you have over here. That comes as 182 for the answer for this question. Chalo, moving on. Find all the values of x which satisfy this inequality. Can we factorize this directly? Yes, we can. Cot inverse x minus 5 into cot inverse x minus 2, right? Is greater than 0. So you have the idea that either cot inverse x has to be less than 5 or greater than greater than 5 or less than 2. Greater than 5 is not possible. Why? Because we know that cot inverse of x it belongs to 0, 3.14. So it cannot be greater than 5. That's directly chucked. So it has to be less than 2. So basically cot inverse of x, your cot inverse of x it will lie between 0 to 2 over here. So if you look at the graph of cot inverse x, it looks something like this over here. So somewhere over here you have your 2. So the value of x at that point is cot 2, and for going up until 0, you're going up until what? Infinity. So cot 2 till infinity this is the region where cot inverse of x lies between 0 to 2 over here, which is the required answer for this question. Okay, option B will be the answer over here. Quite a simple question. Moving on. Okay, standard function looks like it. I don't think there should be a problem. If you differentiate, what are you getting as f dash of x? It will be 3x squared plus 2x plus 3 plus cos x. Looking at this expression, we'll need to find the minimum value of this expression, right? Because if that's greater than minus 1, I can say that it is directly 1, 1, else it will be decreasing at certain point. So what is the greatest value? That's minus d by 4a. What is minus d by 4a? Minus of b square minus 4ac, that's minus 36 divided by 4a, that is 12 over here. So what do you have over here? That's minus 32, that's 32 upon 12. This is for sure greater than minus 1. This is for sure greater than minus 1 over here, which means that this f dash of x is always positive. This f dash of x it is always positive expression, meaning that your function always increasing. It will be 1, 1, and as it is cubic, minus infinity, plus infinity, infinity, it will contain entire real numbers in its range. So option A, 1, 1 on 2 will be the answer. Okay. Moving on. Okay, partial fractions ka question. Let's see, I can say this x square minus x plus 2 divided by x plus 1 into x minus 1 ka cube, that's equal to a upon x plus 1 plus b upon x minus 1 plus c upon x minus 1 ka square plus d upon x minus 1 ka cube. Cool. I can write that this x square minus x plus 2 that is equal to a into x minus 1 ka cube plus b into x plus 1 into x minus 1 ka square plus c into x plus 1 into x minus 1 plus d into x plus 1. Let's substitute x is equal to minus 1. When you substitute x equals to minus 1, what will you get? You will get 1 plus 1, that is 4, is equal to a into minus 8. Rest everything will be 0. So from here, first things first, a is equal to minus 2 we have gotten. Okay. Next, can I eliminate something? Let's substitute x is equal to 1. When you put x is equal to 1, what will you get? You will get 2 equals to 0, 0, 0, and I have d into 2. So basically d ka value comes out as 1. Very well, I've got d is equal to 1. Now these are the only two substitutions which we had, right? So now we have to use a little bit of off substitutions, like let's go for x is equal to 0. So when you have x is equal to 0, you will get 2 is equal to, you have minus a, then 0 pe you have plus b, then 0 pe you have a minus c, and then 0 pe you have a plus d. Okay, this is what you have. I can even put in the values over here for now directly. Let's hold it for now. Next, can I substitute something like x equals to 2? So if I put x is equal to 2, what will I get? I'll get 4 equals to a into 1. Over here, what will I get? B into 3. So this is basically 3b. C into 3c. D into 3d. Okay. This is the expression that I have over here. All right. So now I think we do need to substitute. Okay, let's put a is equal to minus 1 by 2. So, and this d is 1. So basically 1 and 2 I can cancel it out. So this becomes 1 by 2 plus 1, that is 3 by 2. So I'll get b plus c, b minus c is equal to 1 by 2. I'll get b minus c is equal to 1 by 2. Over here, 3D, and this I can cancel it out, and I have 3 by 2 equals to 3b plus 3c. Okay, I have b minus c equals to 1 by 2, b plus c equals to 1 by 2. If you add the two of them up, what will you get? You'll get directly 2b equals to 1 by 4, which gives you b equals to 1 upon 8 over here. Sorry, 1 now. 2b equals to 1, which gives you b equals to 1 by 2. But then at the same time, if you equate b minus c and b plus c, c will be equal to 0. That's it. That's all that we wanted. So now integrating, what do you have? Integral a upon x plus 1, that's minus 1 by 2 ln x plus 1. B upon x minus 1, that is what your b 1 by 2, that's plus 1 by 2 ln mod x plus x minus 1. And then plus c, which is 0, so that's 0. And then d mein, so you have now d upon x minus 1 ka cube. So what is the integral? So d is equal to 1. So 1 upon x minus 1 ka cube. What is the integral over here? That's x minus 1 power minus 3 plus 2, that's minus 2, divided by minus 2 over here. So from here now, now in the question, the ABCD that they are looking for, that A is minus 1 by 2, that B is 1 by 2, that C is 0, and that D is equal to minus 1 by 2 over here. Okay? And out of this, if you look at the options over here, A plus D is basically equal to minus 1. So minus 1 is equal to minus 2B. Minus 1 will be equal to minus 2b. So option B will be the answer for this question. A plus D is equal to C minus 2b. Option B will be the answer over here. Okay, okay, it is clear, everyone? Sure. Moving on. So you have been told P of x square plus Q of x cube plus Rx square Cx plus T is this determinant over here. What can we do? We need to find P. So I need to try and eliminate the rest of the coefficients. Right? There's a very interesting method here. Divide on both the sides by x square, x power 4. So I'll get Q upon x, R upon x square, S upon x cube, plus T upon x power 4. That's equal to, now the first column jo hai, divide by x square. So get 1 plus 3 by x, 1 plus 1 upon x square, 1 minus 3 upon x square. Then you have, divide the second column. Here I have divided by x square, here I will divide by x, here I will divide by x, so that everything is used. So 1 minus 1 by x, 2 by x minus 1, 1 plus 4 upon x. Then you have 1 plus 3 by x, 1 minus 3 by x, and 3 over here. Now what I'm going to do is I'm going to put limit x tending to infinity on both the sides, which would give just p on the left hand side and on the right side 1, 1, 1, 1 minus 1, 1, and you have 1, 1, 3 over here. This is all that you have left out at this point. Open the determinant up. You could use properties, or I believe you can even just directly open it out. What do you have? 1 minus 3 minus 1 minus 1 3 minus 1 plus 2 1 minus of minus plus 1 over here. So what do you have? You have minus 2 plus 2. I can just cancel these two out, and I have just left with minus 4. So option B, minus 4, will be the answer for this question. Okay, plain and simple. Quite a basic question over here. Moving on. Find the exhaustive set of all possible values of C such that this is a monotonic increasing function. F dash of x. What is f dash of x? 2 into e power 2x minus c plus 1 into e power x plus 2. Cos 2 and sin 1 are anyways constant, so they don't really play any role. So greater than or equal to 0 is the condition that we have. Okay, let's try to separate c out. Divide on both the sides by e power x. So you'll get e power 2x divided by e power x, that's e power x, minus c plus 1, e power x upon e power x is 1, plus 2 upon e power x is greater than or equal to 0. So basically I have 2 times e power x plus 1 upon e power x jo hai, is greater than or equal to c plus 1 over here. Now e power x plus 1 upon e power x ka, I know the minimum value is what? What is the minimum value of this expression? It is 2. So c plus 1 jo hai, it has to be always less than this minimum value. It has to be less than this minimum value for certain. So that means I can say that c should always be less than or equal to 3. This is the minimum required condition over here, because if c becomes bigger than 3, then at that minimum value of e power x plus 1 upon e power x, it is not going to be bigger than c plus 1. So c should be always less than or equal to 3. That's why minus infinity comma 3 will be the set of values of c. Therefore lambda ka value should be equal to 3. 3 will be the answer for the question. Okay, everyone? Okay, it is clear. Moving on. If the area of the larger portion bound between the curve x square plus y square equal to 25 and y equal to mod x minus 1. Okay, what is the value of b plus c? Now this is going to be a little calculative. So what do I have? I have a circle. Let's draw a circle. Give a circle somewhat like this. And along with the circle, what else do you have? You have a curve y equal to mod x minus 1. So somewhere over here, I have my curve which looks like this. Now you have been asked to find the area present below over here, the larger area, but I can see that the smaller area is a little easier to calculate. So what I will do is I will rather find the smaller area first, and then out of that smaller area, I will minus that from the entire area of the circle. Okay? So I'm going to try and find this area. Also, to get this area, can you see that I can consider my curve, which is root of 25 minus x square, and if I consider this entire region below this, between the x-axis and this curve, and from this, if I remove the area of these two triangles, I can get the required smaller region ka area. Okay, that's more or less what my thought process is going to be. Okay, so mod of x minus 1, over here the function will use the definition x minus 1, here it is 1 minus x. Substituting x minus 1 in x square plus y square minus 3 over here. Using this, what you're going to get, and considering the positive value of x, you will get the point of intersection over here as 4, 3, and over here your point of intersection will come out as minus 3, 4. Okay. So the area of this triangle, jo hai, what will that be? That is over here, this distance is 1. So this distance will be 4. This distance is 3, and the height is 3, 9 and 16. 9 by 2 and 16 by 2. So I can say that the upper part, the smaller area, I can say that the smaller area jo hai, that will be equal to integral from minus 3 to 4 root of 25 minus x square, and from this I will subtract the two triangles ka area, that is minus 9 by 2 and minus 16 by 2. This gives me the smaller area. Understand, this is still the smaller area. Okay, let's first find the smaller area. We need to integrate root of a square minus x square. What is it? It is x by 2 into root of a square minus x square plus a square by 2, that's 25 by 2 into sine inverse of x by a, sine inverse x by 5, limit from minus 3 to 4. Substitute the upper limit, and there's this minus 25 by 2 also. Cannot forget that. Okay, smaller area, let's call it SA. 4 when you put, you will get 4 by 2 into root of 25 minus 16, that's root 9, which is 3, plus 25 by 2 into sine inverse of 4 by 5. Minus, now you substitute the lower limit, that is minus 3 by 2 into root of 25 minus 9, which is root 16, that is 4, and plus what do you have over here, 25 by 2 into sine inverse of minus 3 by 5. So I can take this as this, let's make this minus sine inverse 3 by 5, minus sine inverse 3 by 5, and the entire expression, there is a minus 25 by 2 also. Okay, let's club the terms together. So 4 by 3 divided by 2, and there's this minus minus plus 4 by 3 divided by 2, that is 12, plus this 25 by 2 into sine inverse 4 by 5 plus sine inverse 3 by 5. That's basically two sides, two angles of a right angle triangle over here. That sum will be equal to pi by 2 minus 25 by 2. Now what is this? This right here, which is nothing but 25 pi by 4 and minus 1 by 2, right? Minus 1 by 2. Now this is the smaller area. What will be the larger area? The larger area, I can say, will be equal to the entire circle ka area, which is pi r square. So that's 25 pi minus this smaller area. That's minus 25 by 4 plus 1 by 2. That's equal to 75 pi by 4 plus 1 by 2. I need to take 1 by 4 common. So if I take 1 by 4 common, I'll get 75 pi plus 2. So that means what we are looking for, this b plus c ka value should be 75 plus 2, 77. Is that the answer? Yes. 77 will be the answer for this question over here. Quite a calculative question, this I'll say. It's one of the difficult questions of area under the curve which can be asked. Extremely calculative bit over here. Okay. Do a question. It's a doable question, but again, I would say that you should rather try solving it a bit towards the end. Okay. Chala, moving on. Here we go. What do we have next? This type of questions are always very easy. Just keep on differentiating. So if you differentiate it once, you will get f dash of x is equal to 3x square plus 2x into f dash of 1 plus f double dash of 2. If you differentiate it once again, you will get f double dash of x is equal to 6x plus 2 into f dash of 1. When you differentiate it once again, f triple dash of x, that will be directly equal to 6. So from here, I got one value, that f triple dash of 3 will be equal to 6. That's directly. Now what I'm going to do is, from these first two equations, in the first equation, let's substitute x is equal to 1. That gives me f dash of 1 is equal to 3 plus 2 f dash of 1 plus f double dash of 2. And the second equation, let's substitute x is equal to 2. So f double dash of 2 is equal to 12 plus 2 times f dash of 1 over here. Substitute f dash of 1 ka value over here, and that gives you f dash of 1 is equal to 3 plus 2 f dash of 1 plus 12 plus 2 times f dash of 1 over here. So from here I have plus 4 shifted over there, that's minus 3 f dash of 1 equals to 15. So f dash of 1 will come out as equal to minus 5. Okay, and now that you have got f dash of 1 is equal to minus 5, substitute. So f double dash of 2 jo hai, that will be equal to 12 minus 10, that's equal to 2. So what is your function? The function f of x now is equal to x cube. F dash of 1 is what? Minus 5x square. F double dash of 2 is 2. So 2x plus 6. We have to find f of 2. That's 8 minus 20 plus 4 plus 6 over here. What is that? That's 12, 18. 18 minus 20, that's minus 2. F of 2 is minus 2. Take a mod. What is mod of minus 2 equal to? That will be equal to plus 2 over here. And that is the answer for this question, 2 over here. Okay? Plain and simple basics question. All right, moving on. Okay, a class is 7 students. The average marks of the students is 62. Very well. And the variance is given to you as 20. If a student fails in the exam if he gets less than 50 marks, then the worst case, the number of students who fail is equal to what? Okay. What is variance? Variance is summation xi minus x bar ka square divided by the total number of terms, which is students, which is 27. That's given to you as 20. Now they go over here. Xi minus 62 ka square is equal to 140. Now just think about it. The idea is that we have been asked how many students can maximum fail. Let's assume that even one student fails. The moment one student fails, can you see that his marks will be 49? 49 minus 62 ka square with 13 square, that's 169. That is already greater than this 140 which we have. That cannot happen, as rest of the terms are all square, even if every student gets exactly 62, 0, 0, 0. But even then the variance will be higher than 20. So not a single student can fail in the exam. Not a single student can fail in the exam. Otherwise, the variance will go higher than 20 directly. Okay? So that's why the worst case, the total number of students that can fail will be 0. Okay? That means worst case, best case, every case, there's only one possibility: every student has passed. Every student has actually passed. Moving on, let's have a look at the last question. What do we have? So we have one circle and we have one ellipse over here. Very well. First of all, let's try drawing the ellipse over here. Circle is much more. So ellipse, what you have is, you have been told that the foci of the ellipse is 0, 0 is one foci, and 4, 0 is the other foci, and the major axis ka length is given to you as 6. That means the end point will be minus 1, 0 and 5, 0 over here, giving you the ellipse, which looks something like this over here. Okay. Now from here I can say that what is my center over here comes as 2, 0 over here. Now can I say that this is the distance over here, which is my A wala distance over here? What is the value of A? A is equal to 3. So I can say that 3 times the eccentricity is equal to 2 over here, meaning eccentricity is equal to 2 by 3. Now what is the eccentricity formula? That is root of 1 minus b square upon a square, which is 9. That is equal to 4 by 9. Let's take the root already on both the sides. So that mean b square is equal to what? B square is equal to 5. So if b square is 5, can I say that the end point of this latest rectum will be 4, b square upon a, which is 5 by 3. Now you might think, why did I take this? The reason is, the center of this circle is 4, 3. The center of this circle is what? Given to you as 4, 3, and the radius is given to you as 2. Now can you see that 5 by 3 jo hai, that is actually 1.66. Right, which means the distance between the center and this uppermost point jo hai, that is 1.44. It is actually less than the radius of the circle. So the circle will come in such a fashion and cut the ellipse actually at 2 points, meaning that the number of points of intersection of these two curves will be actually 2, and the answer for this question. Okay, so yes, that is the last question that we have. It's a basic direct manipulation wala question over here. Simple complex ka logic, geometry of complex ka simple application. Okay, so yes, I hope all of you have understood this, and yes, that is it for today's session. I'll see you in the next one. Very best of luck for your other exams as well. Okay, guys. Bye bye.